Welcome to this tutorial video looking at the multiplication of matrices. This will be a two-part tutorial, the first of which will be looking at the multiplication of a 2 by 2 matrix with another 2 by 2, and the second looking at the multiplication of a 3 by 3 with a further 3 by 3 matrix. So the first one, 2 by 2 multiplied by 2 by 2. Actually, before you even try multiplication of matrices, we need to make certain that our matrices are of the correct order. Not all matrices will in fact multiply together. They have to meet a particular criteria. And the criteria is such that the number of rows in the second matrix has to be equal to the number of columns in the first matrix. If this condition is met, then a multiplication product can be formed. So my example here is I have a matrix A with the elements 1, 2, 3, 4 going across the rows, multiplied by matrix B with the elements 5, 6, 7, 8. Now, as you can see, the first one is a 2 by 2 matrix, as is the second matrix B, a 2 by 2 matrix. Now, if the number of columns in matrix A, which happens to be 2, is equal to the number of rows in matrix B, which also happens to be 2, then these matrices can be multiplied. So in this case, this criteria is met. There are 2 columns in A and 2 rows in B. So they can in fact be multiplied. Let's just check this with the TI-Nspire CAS calculator. So this matrix, as a test matrix, was 1, 2, 3, 4, being multiplied by a second 2 by 2, which was 5, 6, 7, and 8. So we can see we have the same number. Let's go back and check the rule first of all. The same number of columns in A as there are rows in B. It's a 2 and 2 in both cases. So when I press enter, it calculates a matrix, which is good. If, for example, we examined a different arrangement, let's try, whoops, I'll undo that one, and we'll do a different order. Let's say we've got 3 rows and 2 columns, and this time we'll use numbers 1, 2, 3, 4, 5, 6. Not very original. And we're going to multiply that by a 2 by 2. And we'll continue with the lack of originality and use 7 8s and a 9 10. Should we be able to multiply these two matrices? In this case, we've got 2 columns in matrix A, or the first matrix, and 2 rows in matrix B, the second matrix. So that meets our criteria in that the number of columns in the first matrix must match the number of rows in the second matrix. So that in fact can be multiplied as well. It's interesting to note that whilst the number of columns in the first must match the number of rows in the second, if we look at the number of rows in the first and columns in the second, which is 3 and 2 respectively, that predicts the order of our product matrix, which is also a 1, 2, 3 by 2. Just a shortcut of predicting the size of a product matrix. Let's try the one that wouldn't work. So let's try a 3 by 2 again, and we'll use 1, 2, 3, 4, 5, and 6, and this time we'll multiply it by let's try a 1 by 2. Call that 7 8. So in this case we've got 1, 2 columns in our first matrix, but only 1 row in our second. So when we try and multiply that, it comes up with a dimensional error, meaning that our matrix cannot be calculated because, as we just stated, we don't have the same number of columns in the first as we do rows to the second, which is why an dimension error occurs. So let's go through the process manually of how we multiply two matrices. Right, we've got two matrices here in a general form with letters A, B, C, D in the first and E, F, G, H in the second. You notice we've got them color-coded to examine the rows in the first and the columns in the second. And the process is quite simple. First, we consider the column of the second matrix, the first column, and shift it across above the row of the first and multiply the elements. So E multiplied by A and then plus G times B. And we've written that here and kept it color-coded. The second position is using the second column. Same thing, multiplying the first row by the second column, and that gives me A times F and B times H. And here we have A times F and B times H. Repeat again, but with the bottom row of matrix A. So again, the first column of matrix B multiplied by the second row of matrix A gives us CE and DG. And finally, the same again, except using column 2 of matrix B. So CF and DH. That's the general form. So it's taking the column of the second matrix and multiplying it by both rows, then taking the second column of the second matrix and again multiplying by both rows of matrix A. Let's look at an example. So in this case, we have 3 by 2 plus 0 by 0 as our first element, as our product. In our second element, we've got 3 by 2 and 2 by 0. Third, we take the bottom row of matrix A, 3 by 1 and 4 by 0. And then finally, we take the second column of matrix B against the second row of matrix A, 1 by 3 and 4 by 2. And that gives us our answer. We can do this really rapidly and quite simple with our CAS calculator. Let's go on New Document and type this in. So we've got a 2 by 2, and the values we had were 2, 0, 1, and 4. Shift 8, which gives us our asterisk, and we're going to multiply that by our second matrix, which is a 3, 3, and a 0, 2. Press the enter or return. And there we have a 6, 6, 3, 11, which was the same as our 6, 6, 3, 11. So that is a 2 by 2 multiplication with another 2 by 2. Let's look at a slightly larger one and consider the process. Multiplication of matrices. Let's have a look. We're looking again at the general formula, A, B, C, D, E, F, G, H, I against the J, K, L, M, N, O, P, Q, R. So we can follow, we've got them color-coded. The rows in the first matrix A have been color-coded, as have the column in the second matrix B. So the process is the same. We take the first column of B and multiply it with the first row of A. Then we repeat this for the second column and the third. Then we take the first column of matrix B and multiply it by the second row. Now we bring in all these green D, E, and F elements and repeat for the second column of matrix B and the third column. And finally we take the bottom row of matrix A and do the same again. We multiply by the first column of matrix B, the second, and the third. You can see the common factors here. All these elements in our final product matrix are from the first column. They're blue coloured. All the elements in the second column of our product matrix involve K, N, and Q, the black letters. And finally, all the elements in our third column involve the orange. Likewise, all the elements across our first row of the product matrix involve A, B, and C. Second row involve D, E, and F. Third row, G, H, and I. There is a definite pattern here. So let's give this an example using our calculator again. So we're going to select, in this case, a 3 by 3. 1, 2, 3, 4, 5, and 6, 7, 8, and 9, and we're going to multiply it by any other matrix that has got 3 columns. So we'll go with a 3 by 3 again. Let's continue our pattern. 10, 11, 12, 13, 14, 15, 16, 17, and 18. Now, because we've got such large terms, when we multiply 3 of these together to find a single element, we're going to have large values And there's our answer using the TI-Nspire. Pretty straightforward using your calculator to multiply matrices. I hope that's helped. And thank you, of course, for watching.